All right, also test one review, 20 questions. And you don't have to send me work on the review, just the test, okay? So remember on the test, I won't work on 5, 7, 10. All right, let me let some in real quick. All right, 5, 7, 10, 13, and 15. But remember, that's the test only, okay? All right, so on this review, number 1, graph the equation by plotting points. All right, the equation they're giving me, 6y plus 3x equals -3. So I'm gonna do it on the calculator, but in order to do this on the calculator, we got to solve this for y. So what we want to do, move the 3x to the other side. Once we move the 3x to the other side, we'll divide everybody by the 6. So to move the 3x, since it's positive, we're going to subtract it from both sides. So that 6y will come down. 3x, -3x cancel on the left side. Now I'm just going to put the x's first since these are not like terms. So I'm going to make this a -3x minus 3. All right, y'all. Then at that point, divide everybody by 6. All right, so here we go. 6 divided by 6 gives me a 1y right here. -3/6. I'm going to reduce that fraction because both of these will divide by 3. So that'll give me a -1/2 x minus 3 divided by 6 gives me another 1/2. So if you're using the calculator, you would go to y1, plug this in, get you 2 points, and graph it in MATLAB, okay? So I'm actually doing everything by hand on this. So I'm just going to make me up an x and y. And on this one, I'll probably just use 0. And then I'm just going to use a 1. Because you got fractions everywhere, so we're probably not going to be able to get rid of the fractions on this. So let's see what happens. If I put a 0 in for the x, 0 times -1/2 is 0. So I'm just going to put in my 0 first. All right, so -1/2 times 0, like I said, is 0 minus 1/2. That's going to give me a -1/2. Now, since this fraction had halves under everything, MATLAB will divide the scale up in halves on that, okay? All right, now let me put my 1 in. Well, -1/2 times 1 is a -1/2 minus 1/2. Remember, subtracting fractions, everything happens on top, and we put that over 2. So -1 minus 1 gives me a -2 over 2, which turns into a -1. All righty, so let me draw my x and y. So pretty small numbers, but here's what MathLab's going to do on this. They will make little half marks in between all the whole numbers. So like 1/2, 1, 1.5, 2, 2.5, 3. They'll put halves in between everything on MathLab. Whoops, those are negative. Alrighty, y'all. So 0, -1/2. I would start at 0, go down to the first tick mark, which will be the -1/2. So it'll between the 0 and the -1 on that one. And then I had one -1. So I'll go all the way to 1. Remember, it's separated in halves. So go through the half and get to 1. And then at 1, go down 1. Okay, so be careful. You can't just move a tick mark because they're split up in halves. All right, at that point, come through and draw your line. Now, on this graph, it's a straight line. So in MathLab, you're going to use the line tool. So use the line tool and plot any 2 points that you find, okay? Now, I'm going to show you this on the calculator. Now, the calculator, I would have to put it in at this point. -1/2 x minus 1/2. So I'll go to y equals. So -1 divided by 2 and my x minus 1 divided by 2. So y'all, there's my equation. So let's look at the line, because remember, ours sort of went downhill left to right. So there's our line going downhill. And remember, if you wanted to use points from here, hit second graph for the table. And if I was choosing points on here, I would either use -1, 0. I might come down and use 1, -1, 3, -2. That way I could avoid those fractions, okay? All right, so question on that number 1. So y'all, the first 3 are definitely going to be graphs for you. So remember, the first one, you're using the line tool. The second one, we're going to graph. Y equals x squared plus 4. All right, so by hand, I'm going to go straight into making my table, because this one's already solved for y. So that means I can get my x values, plug it in, and then come up with my y values. Now remember, this is a parabola. It's going to be the U-shaped graph. Okay? And that graph has 3 dots on it, which means we need 3 points to plot it. Now, every time I've ever done the x squared graphs, the 3 x's I use are -1, 0, and 1. And we should get the same answer for the -1 as we do with the +1, okay? So you put a -1 in first. Well, -1 squared is 1, so you get 1 plus 4, which is 5. If we put a 0 in, we get 0 squared plus 4, which will be 0 plus 4, which will give us a 4. All right, now we put a 1 in. All right, 1 squared is 1, and we get 1 plus 4, which gives us 5. So on your number 2, if you're using these 3 x values, when y value for -1 has to equal the y value for a +1 on these, okay? All right, so I got 3 points. All right, so remember in MATLAB, you have to use the 3-point quadratic tool. All right, y'all, let me go out about 5 on this. That was my biggest number. All righty, so -1, 5 will be left to -1 and up 5. 0, 4 will be at 0 and up 4. And then 1, 5 will be right 1, up 5. When you put the last point in MATLAB, it'll come in and draw your parabola for you, okay? So 3-point quadratic tool on number 2 for sure. All right, questions on those 2 yet? Righty, so the third one is another graph. We're going to graph y equals absolute value of x minus 3. All right, this graph is picky. Now it's going to use a 2-point absolute value tool. When you got absolute value, it will make a V-shaped graph. And the first point I choose to graph has to make this equal 0 inside those bars. And so I got an x minus 3. That means my first x has to be 3 on this one, okay? Because the first point you plot, when you put 3 minus 3, you get 0. Absolute value of 0 is 0. So y'all, very important when you graph this, the first point we plot has to have a y value of 0 on this graph. So first point we plot must have a y value of 0 for this graph. Okay, so they might give you x plus a number, x minus a number. Pick whatever x makes it equal 0. And then, since I got a 3 there, my next one, I'm just going to use a 4. It don't matter what second x I pick, but it is very, very picky about that first one, okay? So I can put a 4 in here. 4 minus 3 is 1. Absolute value 1 is 1. Okay, and you'll notice on this, since absolute value, the numbers come out positive, that makes sense that all your y values better be positive on this graph, okay? All righty, so for this graph, I'm going to go out about 5 again. And I'll graph this one on the calculator because some of y'all might have forgotten how to get the absolute value on it. All righty, so 3, 0 has to be my first point, has to be on the x-axis. So go right 3, 0 for the y, and put your first point. And then whatever other point, so I used 4, 1. So I'm going to go right 4, up 1. Y'all, when I do that in MATLAB, it's going to put my V-shaped graph for me, okay? All right, so I'm going to do this one on a calculator in case y'all forgot where that absolute value was. All right, so I'm going to go y equals and clear that out. So remember, to get absolute value, you had two ways. You could hit math, arrow over to number, and it's option number 1. And I could hit enter right there. All right, that's one way to get it. Second way to get absolute value is if you hit the blue second button and then the 0 button. It brings up a catalog. In the ABS, absolute value is the first thing on it. All right, then I had an x minus 3. All right, I'm going to arrow out. So there's my y equals absolute value x minus 3. So let me show you the graph. So there's the graph, it coming down, hitting that 3, 0 and going back up. And then remember, if you wanted points on this one and you're doing it by hand, you got to arrow down until you find the x value that has a y value of 0. The y value 0 has to be the first point you plot, okay? All right, y'all, question on those. All right, so those problems mainly came out of section 2.1 and 2.2 on the graphing, okay? All right, so number 4, we're going to determine whether the correspondence is a function. So they're giving me a little table that has a domain and a range. All right, now this is one where they had the arrows. So the domain is -2, 3, and 6. The range is 4. All 3 of these are pointing to the 4. Now this one will have, I'll just show you the picture. It'll have 4 answers. No, because an element in the domain corresponds to more than one element in the range. Yes, because each element in the domain corresponds to exactly one element in the range. No, because an element in the range corresponds to more than one element in the domain. Or yes, because each element in the range corresponds to exactly one element in the domain. Well, when we did this stuff, we said in order for this to be a function, all the x values could only point to one y value or range value. So it depends on the domain, remember. The domain can only point to one range. Well, y'all, -2 only goes to one number. 3 only goes to one number. 6 only goes to one number. So yes, this is a function. And it's a function because each element of the domain, we're getting tongue-tied. Each element of the domain corresponds to exactly one element in the range. Okay, so make sure you get the right reason, okay, because it's the domain that corresponds to one element in the range on those. All right, y'all, then they want us to find the indicated outputs for f of x equals 4x squared minus 4x. So for the first one, they gave me f is 0. So f is 0 wants me to put a 0 in for both of these x's and then hit it with order of operations. So that's going to give me 4 times 0 squared minus 4 times 0. We got zeros being multiplied everywhere. 0 times 0 is 0, times 4 is 0, minus 4 times 0, which is 0. So this is a big 0. Once you put in that answer, they'll pop up f of -1. Well, f of -1 wants me to put a -1 in for both my x's. All right, so let's see. Exponents first. So bring down that 4. -1 times -1 is a +1. And I'm just bringing everything else down. So I just did my exponent on that step. Now I'm going to multiply. 4 times 1 is 4. Now look here. Minus 4 times -1. That's like adding a 4. So these two negatives make a positive. And then 4 plus 4 gives us 8. So once I punch in 8, it'll ask me to find f of 2. So put a 2 in for both the x's. 4 times 2 squared minus 4 times 2. All right, so I'm going to do the exponent again. So bring the first 4 down. Well, 2 times 2 is 4. And I'm just bringing everything down. All right, so I'm going to multiply here. 4 times 4 is 16. Now I got a -4 times that 2, which will be a -8. And then, y'all, 16 minus 8 gives me a final answer of 8. All right, so number 5, you'll have to find 3 values. Now, it always starts out with 0, and then they'll probably give you a negative number and a positive number, okay? All right, y'all, number 6, determine if the graph is a function. All right, so y'all, I'm going to give you a rough draft of this. So this graph I got looks like a sideways looking parabola. So what do y'all think? Is that a function? And you're doing the vertical line test of that. And look at that. No matter where I put a vertical line, I'm hitting it here and I'm hitting it here. I'm hitting it up here.
Yes, it's a function.
Oh, but remember, go the other way. Because remember, if the vertical line intersects it more than once, it is not a function. So y'all, on this one, you got to put no. Remember, to be a function would be something like a parabola. Remember, the vertical lines only intersect it once as you're going through. And y'all remember, these x values can't have more than one y value. So that's why this is sort of violating that, okay? All right, number 7 starts getting into the domain. So find the domain. Find the domain of the function. G of x equals 5 over 6 minus 5x. So remember, it can't be all real numbers because I got a fraction here. So what we did on the ones with the fraction, since we cannot have a 0 in the bottom of the denominator, we said 6 minus 5x equal to 0. Once we solve this, we will exclude any answers from our domain. All right, y'all, so to solve this, I'm going to subtract 6 to move it over. So notice that cancels. I got negative 5x on the left side. That'll equal negative 6 on the right side. All right, then divide everybody by negative 5. So this side, negative 5 divided by negative 5, give me a 1x like I needed. Let's see, 6 will not divide by 5, but y'all, one thing, a negative divided by a negative makes that a positive 6/5. So the answer you would choose on this would be x such that x is a real number and x cannot equal 6/5. Now there'll only be one answer that'll have the right number, but make sure you pick the one with the right symbol. Because some of these they use greater than and less than, which is not true. We need the one that says not equal, okay? All righty, so after we did a little domain, we got into doing what we call the algebra of functions. So on this problem, we're going to let f of x equal negative 10x plus 11. G of x is going to equal x squared plus 13. They want us to find f of 8, f of 8 divided by g of 8. All right, so we got a little division going on, but they're giving me numbers to put in for these x's. So I'm going to do f of 8 divided by g of 8. So I'm going to make it look like a fraction here. F is on top. Negative 10 times 8 plus 11. So I'll put an 8 in for the x on top for the f. Now I'm going to put an 8 in for the x on g, and that'll give me an 8 squared plus 13. All right, so now it's just work the top, work the bottom, and then my final step, I'll try to reduce that if I can. So on top, multiply first. Negative 10 times 8 is negative 80 plus 11. 6 squared is 64 plus 13. All right, let's see what we get here. Negative 80 plus 11, that's going to be a negative, let's see. Looks like 69. On bottom, 64 plus 13 is 77. And y'all, I don't think that'll reduce, but I'm going to check it on the calculator real quick. Remember on the calculator, we can do negative 69 divided by 77. Hit enter. It'll give me a decimal. And I'm going to hit math and enter twice to turn this back into a fraction. And notice I get the same negative 69 over 77. So that tells me it does not reduce. All right, y'all. Number 9. Let f of x equal negative 4x plus 4. G of x is going to equal x squared minus 2. They want me to find the difference g minus f of x. So remember, g minus f. Now, when I do these, my first step, they didn't give me a number to plug into this one. So it's going to end up with x's no matter what. But I make this my g minus my f. Subtraction, you want to start out with parentheses no matter what. And then let's put the g first, x squared minus 2. And then the f, which is a negative 4x plus 4. Now, the whole thing about this problem is when you drop parentheses, you gotta distribute that negative, okay? So if we drop the first parentheses, those stay the same. X squared minus 2. But here, a negative times a negative makes that a positive 4x. A negative times a positive 4 makes that a negative 4. So distribute that subtraction, okay? All right, now I'm just going to put it in order and add like terms. So I got an x squared. I got a 4x. Y'all, my like terms are going to be the negative 2 and the negative 4. That's my like terms. And that's going to give me a negative 6. So my final answer would be x squared plus 4x minus 6. And I'll tell you where I get everybody is on that one sign right there. If you don't distribute the negative and you make that a plus 4, it'll mess up your like terms when you're adding them and throw your answer off, okay? All right, number 10 is the same thing. Let's see. This one says let f of x equal x squared minus 4. G of x will equal 17 minus x. They want us to find f minus g of 7. Now, this one's not too bad because they're giving me a number this time. So here I go. I would do f minus g of 7 will equal my f minus my g. So remember, I'm putting a 7 in for the f. So that's going to give me 7 squared minus 4. G will be 17 minus that 7. So remember, when it's f minus g is 7, you're putting 7 in for all the x's here, okay? Now look, this one you could work inside here, and your last step will be subtraction. So the first parentheses, 7 squared is 49 minus 4. In the second one, only got one step. 17 minus 7 is a 10. All right, y'all, first parentheses, 49 minus 4 gives me a 45 minus, all that's left over here was my 10. You look at that, 45 minus 10 gives us 35. All righty, so that's the first half of it. Any questions on this? All righty, y'all. Let me turn my pages over. All right, so now we're on the second 10. So starting with number 11. So for the pair of functions, f and g, determine.
Mr. Rathbon,
Uh-huh.
sorry to interrupt you. I was wondering if it was okay if I left. I have to go pick my mom up from work.
Okay, yeah, that'll work. I'll send this video out about an hour after class.
Okay, thank you so much.
Okay, no problem. All right, y'all, so you're going to determine the domain of the sum, difference, and product. Now, sum, difference, and product of the two functions. All right, y'all, so for this one, f of x is going to be 1 over x minus 8. G of x will equal 2x to the third. Now remember, on number 11, when it asks you for the domain of the sum, difference, and product, they're all going to be the same. So whatever you get for the sum will be what you put in for the difference and product on this one, okay? So let's just figure out the sum. So the sum of these two functions will be f plus g of x. So we'll put in our f plus our g, which is 1 over x minus 8, and then g is 2x to the third. So I'm doing a domain problem. And if you notice, the one thing I'm worried about in domains, I got a fraction here. So since I got a fraction, this denominator cannot equal 0. So we would have to set x minus 8 equal to 0 and solve that. Because whatever answer I get makes this equal 0, which makes it undefined, which means we got to throw it out of our domain. So y'all solving that, I'm just going to add 8. And I get x equals 8. So let me see what my chat's saying. Okay, Michelle, that's okay. Oh, okay, I was wondering who Bianca was. Okay, thank you then. I got you. So let me see. All righty. So kick 8 out of the domain. So the domain will be x such that x is a real number and x cannot equal a positive 8. So then you look at the difference. The difference would be f minus g of x, which will be my f minus my g. And it's basically the same other than the plus is now a subtraction. And then 2x to the third here. And guess what? Still worried about this one fraction, but we know x can't equal 8 for that. So that means the domain will still be the same. X is real number. And x cannot equal 8. So they'll give you like x is a real number, and then they'll have a big box. Just put in your x not equal to 8. And then the product, well, y'all, that'll be f times g of x, which will be my f times my g. So 1 over x minus 8, and then my 2x to the third. And for the third time, I'm still only worried about this fraction, which means if we put the 8 in, it makes it undefined. So it will have the same domain, x, such that x is a real number. And x cannot equal 8. So y'all remember number 11, they're all three going to be the same on this one, okay? Because you're going to have a fraction and then something like this, either a cube or a square or something, but you're only worried about the fraction on that. Now, the one we didn't do was division, but guess what? Number 12 is doing this for division. So this one says for the pair of functions, f and g, determine the domain of f divided by g. Okay, so let's see. F of x, they said, is 7x minus 5. G of x is 5x minus 35. So let me see what kind of expression I'm going to get when I plug in for f and g. So f divided by g of x will equal my f on top, 7x minus 5, over my g, 5x minus 35. Now remember, since it's a domain, all I'm worried about is this bottom cannot equal 0. So we would come in and set 5x minus 35 equal to 0. And y'all look at that. 11, 12, and I think there was one earlier where we did the domain. It's only the bottoms you're worried about on all of those, okay? So let's see, solving that for the x, we're going to add that 35 to move in. So this 5x, that stuff cancels on the left side. Right side, I get 35. And then I'm going to divide by 5. So look here, 5 divided by 5 gives me 1x like I wanted. And then 35 divided by 5 gives me a 7. So for this one, x such that x is a real number. And x cannot equal positive 7. Now, what's nice on these is you only got to write this part that I'm putting in the box. It'll have everything else written for you, so you don't got to sit and type all that in there, okay? All right, so those were the main ones that started hitting us with the domain, okay? Just make sure you pick the right symbol and then put in your number. And you gotta have the x in these, okay? Y'all, if you don't put the x not equal to 8, x not equal to 7, MATLAB marks those wrong, okay? So be careful. Oh, now we get into the composition, y'all. So composition was when I had that little degree symbol. So given f of x equals 2x plus 1, g of x equals x to the third, we're going to find f compose g of a -1. Now remember, compositions, this is where I put the -1 into the g, get that answer, and put it into the f. So it's like we're finding f of a g of a -1. Okay? So first is the g of -1. So g of -1 will equal me putting a -1 in for that x and then cubing it. So -1 to the third power. Well, y'all, negative times negative times negative is a negative, and 1 times 1 times 1 is 1. So -1 to the third power gave me a -1. So that means we're now going to find f of that -1. So this -1 goes into the f now. And the f equation is 2 times -1 plus 1. Now, y'all might not get -1s. You might get -2. And this answer might not match what you're putting in, okay? So just be careful what they're giving you. All right, also here, multiply first. 2 times -1 is -2 plus 1, which gives me a -1. So I don't think y'all's will be quite so repetitive if you don't get a -1 there, okay? But that's how mine worked out. So final answer, -1. All right, 14, use horizontal line test to determine if its function is 1-to-1. So this is sort of like the vertical line test for functions. So this one, they gave me a picture that sort of comes up on one side like this, down on the other side. And then in the middle, it sort of makes a U shape. So horizontal line test is like the vertical line test. If a horizontal line that I'm putting here can intersect a graph more than once, the graph is not 1-to-1. So y'all look, if you draw horizontal lines, it intersects it once, twice. Intersects this part once, twice. Since it's intersecting it more than once, this would be no, not 1-to-1. Okay? So y'all remember that. Vertical line test on functions can only intersect it once. If it does it more, it's not a function. Horizontal line test for 1-to-1. If it intersects once, it's 1-to-1. If it intersects more than once, then it's no, not 1-to-1. Okay, so 15 actually uses this. 15 will say determine if 1-to-1. Then it says if it is, find a formula for the inverse. Okay. So my 15, I got f of x equals 9 over x plus 4. So, y'all, automatically, 15 is yes, it will be 1-to-1. So no matter what, it's going to be 1-to-1 for 15. So if you put no, you're definitely going to miss it. Because I found a problem that would always be yes for this. Because you got to find the formula for the inverse, okay? So, since it's going to have an inverse, we replace the f of x with a y. We then switched the x and y around so that we get x equals 9 over y plus 4. All right, so we're solving this for the y. And y'all, I'm going to tell you the easiest way to solve this one is multiply both sides by y plus 4. Because by multiplying both sides by y plus 4 here, on the right side, those y plus 4s cancel. Now, I'm not going to distribute this. I'm going to leave this a y plus 4 times x equals 9. And y'all, I'm still not going to distribute this. What we're going to do now is divide both sides by the x. So y plus 4 times x divided by x will equal this 9 divided by x. So we did that because these x's cancel. All that's left on this left side is y plus 4. So that'll give us y plus 4. On the right side, we got 9 over x. Now, my last step, subtract 4 from both sides. So notice, bring down the y. The 4's cancel on the left side. You got a 9 over x minus 4. Those are not like terms. So we're going to leave that 9 over x minus 4. Now, my last step was to replace the y with the f negative 1 of x. So remember, this is inverse function notation. It's going to equal 9 over x minus 4. In MATLAB, all you got to do is put in the 9 over x minus 4. MATLAB will already have the f negative 1 of x sitting there for you, okay? All righty, so now you could distribute the x here and work it a different way, but that way sort of is longer to me. So questions on this page. All right, y'all. Now we start getting into the systems of equations. So 16 says solve. Solve the following system by elimination. They're giving me 5x plus 4y equals 44. 4x plus 5y equals 46. All righty, so are y'all doing this on calculator or are y'all mainly doing this by hand? So y'all can let me know which way y'all are going.
By hand.
Okay.
I
So
use
by
the
hand.
calculator.
Now, if you do use the calculator, remember this will be 2 rows by 3 columns. So on the calculator on your matrix, it'll be a 2 by 3, okay?
Yes, sir.
All righty. So by hand, and oh, they both got 4s and 5s. So I guess I'm just going to eliminate the x. But really on this one, it don't matter which one you eliminate. They're both the same. So if I'm going to eliminate these x's, the smallest number 5 and 4 both go into would be 20. So I'm going to multiply the top row, this top equation, by a 4. Because 4 times 5 will make that a positive 20. The second row here that's got a 4x, I'm going to make this a negative 20 by multiplying that row by a negative 5. So 4 times 5 here will give me a positive 20. Negative 5 times 4 will give me a negative 20. So remember, the 4 gets distributed to all 3 of these. So 4 times 5 gives me 20x. Plus 4 times 4 is 16y. That's going to equal 44 times 4. I think that's 176. So 176. Then this row, I'm going to multiply everybody by negative 5. So I'm going to get a negative 20x. Negative 25y. And then negative 5 times 46 is a negative 230. But now when I add these, y'all, the x's cancel. So negative 25 and 16 will give me a negative 9y. Negative 230 plus 26 plus 176 gives us a negative 54. So now we're happy. We got one variable. So we can divide both sides by that negative 9 and know what that y equals. So y'all look here. Negative 9 divided by negative 9 makes that a 1y. Negative 54 divided by negative 9 gives me a positive, what's that, 6? So guess what? You know what y is now. So now we back substitute. And I can pick either equation I want here. Since I know what the y is, I can pick that one or that one. So I'm just use my first one. So I got 5x plus 4 times y, which is 6, equals 44. So remember, multiply first. So bring down to 5x. 4 times 6 is 24, equal to 44. So now it's just a matter of solving for the x, y'all. So subtract 24. So let's see, I get my 5x. 24 is cancel. 44 minus 24 leaves us 20. And y'all, that's it. We'll divide by 5. So 5 divided by 5, there's my 1x. And x will now equal, what, a positive 4. But y'all, this one's tricky. When you put this in Math Lab, you gotta put it in ordered pair. You gotta have parentheses, and then these gotta be in alphabetical order. So the X is first, which is 4. The Y, which is 6, is second. All right, y'all. So that's the trick. Eliminate one variable, solve for that other one, okay? All righty, so I'm going to turn my page over because number 17 is the same thing with 3 variables. So this one says solve 7x minus y plus z equals 4. So there's my first equation. Then I got 2x plus 2y minus 3z equals 6. And then finally I got x minus 3y plus 2z equals a negative 10. All right, so let me make sure I got all my numbers right. You hate doing these knowing that you got one number wrong and it messes you up. All righty, y'all. So, are you doing this one by hand? Anybody? Oh, I'm not hearing nothing, y'all. All right, so calculator or hand. What y'all got?
By hand.
Okay, that's what I was going to do. All righty. Now, calculator, this would be 3 by 4, okay? So by hand, let me see what I want to choose here. So nothing eliminates right off the bat here. So the X's, Y's, or Z's. So let's see. I mean, looks like they're all about the same difficulty. And he just has an X, a Y, and a Z, so it really don't matter. So y'all, for me, I think I'm going to eliminate the Z. Now remember, I'm going to make 3 equations. Now my first major step is to turn these 3 equations into a system of 2 equations like number 16 was. So we're going to shrink this from a 3 variable into a 2 variable by eliminating that Z. So what I'm going to do first, I'm going to add 1 and 2. But 2 has a negative 3. 1 has just a Z. So I'm going to multiply row 1 by 3 so that I get a 3Z here. That'll cancel with my negative 3Z. So I'm going to multiply 1 by 3 and add 2 equation 2, okay? So if I multiply by 3, that's going to give me 21x minus 3y plus 3z, and then 3 times 4 is 12. So I multiplied equation 1 by 3, then I'm going to bring down 2 to add to it. 2x plus 2y minus 3z equals 6. Now, when I get through adding these, this will be my new equation number 4. So let's see what we got. 21 and 2 gave me 23x. But right here, negative 3 and 2 give me a negative 1y. But y'all, the z's cancel. And then on the right side, 12 and 6 give me 18. All right, so here's what we got. This is the first equation of the two variable system. Now, since I used equation 1 and 2, this time I got to use equation 3 with one of the other ones. So check this out. Since I got a 2z here, I'm going to change the first row again and multiply by -2, because that'll give me a -2z. That'll cancel with a positive 2z. So I'm using row 1 again on this system. So this time I'm going to multiply 1 by -2 and add 2 my equation 3. Okay, so that's the trick. You got to use all three of these equations, but one of them is going to be used twice, and that was my equation 1 here. So let's multiply equation 1 by -2. I'll get a -14x minus 2y plus 2z, and then 4 times 2 gives me 8. Row 3, I'm not changing. X minus 3y. Whoops, hold on. That's a let me get some signs here. That was a -2z because I did -2 times z, and then this should be a -8. So y'all, my bad. Let me see if that's what my chat was saying. Okay, no problem. No problem. All right, so now bring down to plus 2z equals -10. All right, y'all bad. So -2 gave me -14. -2, that's going to give me a positive 2y there. So -2 times -1 made that a positive 2. 1 times -2 is -2z. -2 times 4 was -8. So I was looking ahead, but remember, -14, 2, -2, -8. Now we add these together. -14 and 1 gave me -13x. 2 and -3 gave me a -y. The z's cancel. And then a -8 and a -10 give me a -18. Y'all, that will now be our equation 5. So we're going to put 4 and 5 together now. 23x minus y equals 18. -13x minus y equals -18. So now I think what I'm going to eliminate on this one is the y, because I got a -y and a -y. I'm going to multiply the second equation by -1. So I'm not changing the top one. Let's bring that down. 23x minus y equals 18. This will make this negative times negative, positive 13x. Negative times negative, positive y. Negative times negative, positive 18. All right, y'all, so I'm happy the y's finally cancel. 23 and 13 gave me 36x. 18 plus 18 gives me 36. So it now looks like we can solve that for the x. So y'all, I'm going to divide both sides by 36. So that cancels, giving me my 1x. And then 36 divided by 36 gives me a 1. So remember, we back substitute this x into one of these two equations that we have x's and y's in. Once we find that y, then we'll go back into one of those original 3 I had, okay? So this is now time to back substitute. So y'all, I'm just going to use this first one. 23 times x, which is 1, minus y equals 18. Okay, I'll solve that. Once I got that one solved, I'll go after the z, okay? 23 times 1 is 23 minus y equals 18. Subtract 23 from both sides. I get a negative y equals a negative 5. And then remember, divide both sides by that negative 1. Because our y has to be positive. So negative divided by negative makes that a positive y. Negative divided by negative makes that a positive 5 on that side. So x is 1, y is 5. So I'm going to use one of my original equations. And I'm going to use my first one. It said 7x minus y plus z equals 4. I got 7 times x, which is 1, minus y, which is 5, plus a z has to equal 4. Y'all multiply first. 7 times 1 is 7, minus 5, plus z equals 4. On the left side, add like terms. 7 minus 5 is 2, plus z equals 4. And y'all look, my last step, subtract 2. So that cancels. I get my z. 4 minus 2 is 2. Now, this one, MathLab gives you the parentheses. MathLab gives you the parentheses. You're just putting in the 3 numbers, alphabetical order. So the x was 1. My y down here was 5. And my z was a 2. All right, y'all. So let me ask. Anyone want to see it on the calculator? Need a refresher?
No, sir, I'm good.
All righty. So, sort of fun by hand, if you like doing that kind of stuff. And y'all, now the rest of these is just graphing the inequalities where we had to shade. So this one says graph the inequality. Three x minus 2y less than or equal to a negative 4. All righty, so you got to solve this for the y, but you're dealing with an inequality. So let's see what we got to do. We need to move the 3x over by subtraction. All right, so them 3x's cancel. I end up with a negative 2y less than or equal. Remember, these are not like terms, so I'm just going to put my x's first and then my minus 4. So then you have to come in, divide everybody by negative 2. Which means since I divided by negative, I'm going to reverse my inequality. And instead of a less than, it's now going to be a greater than or equal. So reverse inequality. Since dividing by a negative. And y'all, I'm pretty sure everybody's going to have a negative in front of their y. So be careful. If it's negative, it will flip. Because it's negative 2 divided by negative 2 makes that a 1y. Greater than or equal. Negative divided by negative makes that a positive 3/2 x. Minus a 4 divided by negative 2 makes that a positive 2. So by hand, I would find me 2 x values. So on this one, I'm going to use 0. I always use 0. And since this has a fraction in front of the x, I'm going to use a 2 so that I can cancel that out. All right, you also put a 0 in. 0 times 3/2 is 0. 0 plus 2 gives me 2. Now, if you're doing this on the calculator, at this point, you could plug this into y1, okay? Now, if I put a 2 here, the 2's will cancel, and I'm left with 3 plus 2, which is 5. So I always use a number for my second x that'll cancel this fraction out, okay? All right, so I got 2 points. Y'all, the first thing, you got to use the line tool. Since that's got an equals under it, you're going to choose the one that's a solid line, okay? If you didn't have equals, then you would use the dotted line, okay? Now, by default, it's on a solid line, so I'm good on this one. So let me go out about 5 on this. So 0, 2 will be at 0 up 2. 2, 5 will be right 2 and up 5. Now at that point, it's going to draw a solid line because that's what's chosen by default. Now the question is, am I going to shade this above the line or below the line? Well, this is greater than. You got to go by this equation right here. Since that's greater than, I would highlight that little paint can and I would drag that little paint can to this side. Once I drag that paint can here, it's going to shade everything above that line. Okay? So, 2 things that are important on this. Choose the right line and shade it using that little paint can. Drag it over. All right, y'all, 19. Graph the linear inequality. And it has x less than 4. All right. That shouldn't be too bad, hopefully. X, Y. So let me go out about 5. So if you was to make you a table up on this one, there's only one x value you can pick. Remember, this is like x equals 4. X less than 4. Remember, when I did these are vertical lines. X's make vertical lines. But this means that every x value has to be 4. I don't care what the y values are. It's telling me x's have to be 4 on this one. Now, you can pick any 2 y values you want. So I'll just use 0 and 1. Plot these 2 points. But check this out. You're using the line tool. But y'all, that is less than. So when you choose the line tool on MathLab, you gotta highlight the dash line box. There'll be a line box and a dash line box. Highlight the dash lines. Plot your 2 points, 4, 0, and then 4 up 1. Notice it makes a vertical line at the x value of 4. Okay. Here's the x value of 4. It's going to be a vertical line. Now, less than. Is less than going to shade to the right or is less than going to shade to the left? Well, guess what? What direction is that pointing? That thing's pointing to the left. So that means we're going to shade the left. So drag that little paint can thing to the left side of the line, drop it, and it's going to shade in all the left side of it. So all these X values over here are less than that X value of 4, okay? All right, so this one solved it for the Y. This one, since it's X less than 4, every X value on this line has to be a 4. So y'all, that means number 20 is going to be the one that we did last, where the two graphs are going to shade and overlap. The overlapping section will be the answer we're looking for. So this one says graph the system of inequalities. So y greater than or equal to x plus 6. Y less than or equal to 5 minus x. So they're both already solved for y. So if you did it on the calculator, put this in y1, this in y2. All right, so I'm doing it by hand. So this will be my first line. And then this x and y here will be for my second line. And I'm just using, I'll use zeros and ones again for both of them. So let's use the 0 and 1 up here. 0 plus 6 gives me a 6. 1 plus 6 gives me a 7. Now the second graph, 0. 5 minus 0 is 5. If I put a 1 in, 5 minus 1 is 4. So it looks like I need to at least go out to 7 on this graph. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, remember, both of these will be solid lines. Now, this one, you don't even have to graph it. They'll give you a picture. And I'll show you. They'll give you 4 pictures. It's either going to double lap over here, double lap on the right side, overlap twice on the top, or overlap twice on the left side. So let's see where it's going to happen. So y'all, I'm going to draw my first line first. 0, 6 will be at 0, up 6. And then I had 1, 7, right 1, up 7. That was a solid line coming through those 2 points. And it's greater than on the first one. So since the first one is greater than, on that one, you would shade it above the line. So that one shaded above the line being greater. All righty. Our second line, let's see what my points were. I had 0, 5. So 0, up 5. I had 1, 4. So right 1, up 4. So that line's coming through those points. It's less than, so it's going to shade below the line. Which means on the test, the region I would pick would be this region that has both the blue and red shading to it. And y'all look here on this graph, it would be D. So it's only going to give you the answer of the double shaded areas, okay? So 18 and 19, you had to physically graph, but number 20, you're choosing out of the 4 different pictures they got, okay? All right, y'all. So here's the thing. Test 1 is now open. And due by Sunday. Sunday will be the 25th. So you got till midnight Sunday Sunday the 25th to finish test 1. Remember, you got to send work for questions number 5, 7, 10, 13, and 15. So these weren't that bad of problems. I picked 5 sort of mellow ones. You can email those to my email or text them to my cell phone. If you text the work, it'll be 501-472-6782. Okay, or you can email them, just take a picture and do them email or text them. Now, y'all, here's the thing. The review counts as a quiz, remember. So do it because it's a grade. And you can do the quiz as many times as you need. So get good on that quiz before you do this test. Because y'all, the test only gets 1 attempt, okay? So I would probably practice that a little bit before that due date with a quiz before I try to hit my test, okay? Now, you can wait till Sunday to do it, but we will start test 2 material on Wednesday night. So new material for test 2 on Wednesday. Now, it won't be nothing major. It's just a minor assignment just to get us into test 2 material. But it's not bad because I wanted y'all to do good on this test, okay? So now another good thing for y'all to do, if you can, try to do your review before Wednesday night. That way, if there's something bugging you on the review, I can probably fix y'all Wednesday night before you do your test, okay? But y'all, the test is open now, so anytime from now to Sunday, okay?
Okay, well, you said like, okay, so the